Good morning, everybody. Please take a seat. Well, welcome to the University of Strathclyde in a magnificent Barony Hall for today's graduation ceremony. I'm Professor Stephen MacArthur. I'm the Principal and Vice-Chancellor of the University, and it's our pleasure to have you here today. In the room today, we have our graduands who have completed their studies, and shortly they will come across the stage. As they come across the stage, I shall cap them, which is an ancient rite of passage, which at that point confers the degree that they have studied so hard for onto them. And at that point, they magically transform from a graduand to a University of Strathclyde graduate. But I'm really pleased that they're joined in the room today by their friends, family, and supporters. And we're joined by people from all around the world who have helped contribute to the success of our students. So today is a joyful, happy celebration of all the hard work our students have put in. So I know we're in quite a large building. It might feel a bit formal, but please let me encourage you that when you see your loved one coming across the stage to get their degree, please feel free to let them know you're here to celebrate. You can make a bit of noise within reason. We banned flares recently, but please celebrate with them, and we're really looking forward to doing that. But also in some of these graduation ceremonies, we also have some other extra special elements, and today we have that, where we honour somebody who has exhibited everything we think that is what we're looking for from a Strathclyde student, but they've done it in their own career. They've exhibited what it is to live the values that we live by and achieved great things. And I'm delighted today that we are conferring an honorary degree on Dame Lynn Gladden, an accomplished engineer, academic, and contributor to society, and you'll hear more about Dame Lynn shortly. At the conclusion of today's graduation ceremony, you'll then be invited to our Learning and Teaching building, joining our academic procession, where we can have an informal get-together and a chance to catch up. So please enjoy today's graduation ceremony. And with that, I declare today's ceremony officially open, and I'd like to invite Professor Tim Bedford to introduce our honorary graduate.
Principal and Vice-Chancellor, I have the honour to present to you Professor Dame Lynn Gladden. Professor Dame Lynn Gladden is Shell Professor of Chemical Engineering at the University of Cambridge, where her many roles, have included that of Pro-Vice-Chancellor for Research. She originally wanted to be a physics and sports teacher, but picked up a sports injury which made her look for something else. That was to be a PhD in the Cambridge Physics Department with a chemist as supervisor, after which she was offered a prestigious Royal Society Pickering Fellowship with up to 10 years of research funding. However, the Cambridge Department of Chemical Engineering approached her as they needed what they called a numerate chemist. She hadn't heard of the subject they wanted, but nonetheless, she made what she describes as the reckless choice not to use her Pickering Fellowship and to dive instead into a whole new research area in chemical engineering. Her new head of department said that she should become a chemical engineer and arranged for an ICI industrial placement, which led her to a whole career working collaboratively with industry to develop new science and engineering methods for solving challenging industrial problems. She's made major contributions to the chemical process industries, realizing that you could take the MRI scanning used in hospitals into an engineering environment. She was able to develop novel methods to measure the complex flows of materials in industrial processes, and in particular, to measure the performance of catalysts. This meant that the mathematical models that had been produced could at last be properly calibrated, produce real, accurate, and above all, useful information. She worked for many years with Unilever, coming to their rescue when Persil suddenly started destroying its customers' underwear, and going on to lead material science R&D across all of the sites, all the time while staying in her own academic role. She's also developed collaboration with international pharma companies based in Singapore, working together with Nanyang University of Technology on carbon reduction and sustainability. Nanyang, one of Strathclyde's international partners, is one of several universities to have honoured her with an honorary degree for her leadership and her contributions to scientific research and innovation. During this period, she also held the position of Pro-Vice-Chancellor of Research at the University of Cambridge, and she led the creation of the only Cambridge University Overseas Research Campus based in Singapore. Professor Gladden's collaborative research approach resonates very strongly with the ethos of collaborative research at Strathclyde. She has said, "My collaborations with industrial partners have given me greater understanding of the questions that industry really needs an answer to, and I have learned a lot from colleagues in industry who have introduced me to new ideas in chemistry and in mathematics." In October 2018, she became the Executive Chair of EPSRC, the Engineering and Physical Sciences Research Council. She ably guided EPSRC through a period of great change for the UK research funding system, understanding well the need to support fundamental research as well as collaborative research with industry. She strongly supported the key and distinctive role that EPSRC plays within UKRI, especially around the support of PhD funding. As part of her broader work since 2020, she has been chair of the judges for the Queen Elizabeth Prize for Engineering, the world's leading award for engineers and engineering. The importance of her contributions to research were recognised in her election to the US National Academy of Engineering and her appointment as Dame Commander of the Order of the British Empire, a DBE, in 2020. Today we recognise her exemplary contributions to research and her excellence in developing deep and productive research partnerships with industry which benefit our wider society. It is with great pleasure, therefore, my Lord Vice-Chancellor, that with the authority of Senate, I ask you to confer upon Professor Dame Lynn Gladden the degree of Doctor of Science honoris causa.
Well, thank you very much, Tim, for that. That felt a lonely 5 minutes or so standing there. I don't think I've ever felt quite so self-conscious. So for those awaiting to get their degrees, I've been there first, okay? And it's scary. Right, so I don't think that was how I was meant to start this either. So Principal and Vice-Chancellor, faculty, graduates and guests. First and most importantly, I want to congratulate all of you receiving your degrees today. It's your day to celebrate with all those who have played such an important part in your success. And of course, in that vein, it's also a very special day for me. It's a great honour to receive the Honorary Award of Doctor of Science from the University of Strathclyde. And in receiving it, I must thank the huge contributions of the very many students, postdocs, faculty colleagues, and industrial collaborators that I've worked with, as well as, of course, my family and friends. And so Tim has referred to some of this. How did I get here and what have I learned? Indeed, from when I was quite a young kid at school, I wanted to train to be a teacher. I went to the University of Bristol to study physics, then chemical physics. Why did I go to Bristol? It was a good university. It is a good university, but it did have the country's best lacrosse team. And that was in my sporting phase. After that, I trained to be a physics teacher, and then studied for a PhD in amorphous semiconductors at Cambridge. And at the end of that PhD, I still intended to teach, but there were opportunities to stay in the research field. But then something happened that changed the rest of my life. Someone asked me if I'd seen an advert for a lectureship position in the chemical engineering department. And that was how I come to be here today, a chance approach by a senior academic thinking that I might fit the skill set of a faculty position that had just arisen in Chem-Eng. So I sent my papers in, had the most shocking interview I can ever remember. I mean, it was quite grueling. And no one could have been more surprised than me when I was offered the job. And taking that job was a tough and a high-risk decision. I knew it was high risk, but when I look back on it, it was even higher risk than I thought it was. I ended up in a job in a field I had to learn from scratch. I knew absolutely nothing about chemical engineering. I did know about physics, chemistry, and maths, which are the component parts. But I didn't know anyone. I had to create my own networks. And when I put these notes together for today, I thought, actually, that's not so different for many of today's graduates. You're entering a new phase of life where you're going out into the world and you've got to make those new networks and make everything happen. So then I had to decide how I would build a research group in a discipline I didn't know. And what I learned, and I'm sure it's very different now, was that chemical engineers were great at modelling systems, but often didn't have the accurate input data. And for those of you who are not chemical engineers bring together knowledge of fluid flows and chemical reaction inside process vessels, which are typically opaque, so they're classic black box, so that you're then trying to design a process when you don't actually know what's happening inside that black box. And at that point, magnetic resonance imaging was just coming into use in hospitals. And it was being used to measure blood flow and, as you know, imaging the internal structure and chemical processes occurring in the body. And so I thought, well, let's take this and see if we can modify the methods, because you do have to change them, to characterize the fluid flows, molecular transport and chemical processes in occurring, for example, catalysis, reaction engineering, and one of our major programs at the moment is carbon CO2 sequestration processes. But finding meaningful problems was difficult if you're new to the field, and that's why I spent many months working in industrial R&D around the world, building up, and this is important, trusted partnerships, knowing the people that are going to want to work with you and that the ideas resonate with, and we would identify the bottlenecks in their processes which we could work together on. So what did I learn from this? I learned to listen and try to understand the way they looked at their problems. I was constantly having to go away and learn. I had to learn the whole undergraduate TRIPOS, the degree course, but I also had to learn how practical engineers operated. But one thing I did learn was the real importance of acknowledging when I didn't understand something. And it is no shame when you start on something new to say, I don't understand. But then to have the courage to make decisions and take risks. And there will be highs and lows, and you just keep going. So later on in my career, I got led astray, as I call it, into other areas where I would never have considered myself suitable for. I became a Pro Vice-Chancellor for Research at Cambridge and then the Executive Chair of the Engineering and Physical Sciences Research Council. However, I always retained my research activity and worked with students, and I like to say, and I think it's very much the case, I don't know what they thought of the experience of me being away on these other things 80% of the week, but the students kept me sane and grounded. So in conclusion, I think you will all agree that science and engineering offer you a great training for life beyond university. At least I hope you believe that. You've all acquired numerous skills, one you may not even realise. You have learned how to think and to think objectively. Use what you've learned, keep smiling, and make the world a better place. Thank you.
Principal and Vice-Chancellor, in the name of the University and by authority of Senate, I present to you these students. For a degree of Doctor of Engineering in Advanced Manufacturing, Forging and Forming, Andrew Barclay. For the degree of Doctor of Philosophy for Research in the Department of Design, Manufacturing and Engineering Management, Khalid Mahmood. For research in the Department of Mechanical and Aerospace Engineering, Damilola Adebola Aji. Louis Samuel Wallace. For research in the Department of Naval Architecture, Ocean and Marine Engineering, Yi Huang. Binquan Wang. For the degree of Master of Philosophy for Research in the Department of Naval Architecture, Ocean and Marine Engineering, Dale Eugene Pedersen. For the degree of Master of Science in Advanced Manufacturing Technology and Systems, Sahil Shekhar Godse. In Design Engineering, Vanshika Gupta. Marcus Miller Livingston. Gabriel Saylor. Matthew John Trevor. In Design Engineering with Sustainability, Harry Christopher Goodman. Jude Cameron Weir. In Engineering Management for Process Excellence, Shaheen Al-Gajri. Najdeep Alije Ramaswamy. Siva Venkata Prasad Batula. Eldo Biju. Rama Krishna Shelikani. Manoj Sanjay Rajeswari. Tejas Anil Shinde. Eloise Marie Laurette Tosello. In Engineering Project Management, Alexander James Lilleman. In Mechatronics and Automation, Nasir Muhammad Ahmed. Leon McNair. Gilbert Alexander North. Gautam Patar. Ansh Narendra Purohit. Nitish Kumar Ravi. Aditya Arun Toraskar. In Product Design, Patrick William Davison. Swarangi Hitendra Deudokakar. Elizabeth Samuel. Beth Simpson. Nina Carey Sterling. In Supply Chain and Logistics Management, Erayambu Agumsani. Kruth Scotwin Anthony Vernon. Muthamil Selvan Baskaran. Sai Krishnan Bhuvaneswaran. Muhammad Aksan Khan. Dexton Jovel Lobo. Harsh Prashant Malbalskar. Salman Sheikh. In supply chain and procurement management, Ryan Ali Abdullah Al-Falahi. In supply chain and sustainability management, Alina Teresa Mayfair Wolf. In systems engineering management, Cheryl Altamirano Bocanegra. Martin Callahan. Rachika Gajanan Chor. Andrew Thomas Cross. Carly Frances Dacre. Samuel Levy Yun. Anthony Francis McCready. Grant David McLaren. Mofijin Foluba Suetan. In advanced materials engineering, Reddy Tulasi Basineni. Kate Elliott. Angus Harold. In advanced mechanical engineering, Haris Ahmed. Aman Zahir Bhatt. Subramanian Ganesan. Shivratna Pravin Moore. Rhys Ottaway. In advanced mechanical engineering online learning, Ben Phipps. In advanced mechanical engineering with aerospace, Tabarek Sabi Qasim Al-Shaikli. Luis Guillermo Agil Andrés. Mirza Muhammad Saad Baig. Harnet Tekel Haftemichael. Erika Lopresti. Kavya Muthu Kumaran. Kanan Ojagov. Finley Charles Stewart. Shidanth Goldav and Taskamwami. In advanced mechanical engineering with energy systems, Roshan Joseph Tommy. In advanced mechanical engineering with materials, Ruth Elizabeth Iruskibela. In sustainable engineering, renewable energy systems and the environment, Ahmed Abdulaziz Al-Shamari. Glenn Anderson. Benedicta Sara Bokedal. Louis Fitzpatrick. Aidan David Hughes. Melonisa Chisinga Mukwasalamba. John Roy Hamilton Steele. In Advanced Naval Architecture, David Albert Xavier Aulanum. Youssef bin Hassan. Lei Him Jasper Chung. Aditya Raj Kochupuralji Ramesh Kumar. Sander Hogan Lee. Shiva Shaji Tripti Kumar. In Marine Engineering, Mudu Lamin Kamara. Georgios Chalkitis. Matei Kidali. Sheikh Usman Ali Basha. In offshore wind energy, David Caldwell. Shahim Asad Karakunev. Tomin Matthew. In ship and offshore structures, John Adefemi Bero. In subsea pipeline engineering, Fahar Satyajati. In sustainable engineering offshore renewable energy, Andrew Scott Tyre. In technical ship management, Trixie Marcia Rofifa. For the degree of Master of Engineering in Aeromechanical Engineering, Justin Ng. For the degree of Master of Science in Product Design and Innovation, Alec Grant Gentleman. Muhammad Sami Regman. For the degree of Bachelor of Engineering in Product Design Engineering, Lucy Buckley. Robbie Burns Dickey McCann. In Sports Design Engineering, Jaya Gill. In Engineering Design and Manufacture, Rory Banks. Alex Biavati Smith. Jack William Cook. Ryan John Dixon. Jenny Dougal. Christy Fallon. Luke Follen. Gavin Forsyth. Marina Hendren. Sophie Hodden. Georgina Rose Heinemann. Kyle Michael Reed Laurie. Mark Thomas Leckenby. Jennifer Mackay. Lauren Helen McNeil. Andrew Daniel McAlpine. Eva McEwen. Michael Francis Alexander McGarahan. Alistair McMonagall. Aaron McQuaid. Lee McSheffery. Sophie Arwin Morton. Jude Oliver Munro. Cameron Robert Nellis. Owen Scannell. Christopher James Smith. In mechanical engineering, Spogmai Bibi. Connor William Harry Chapman Liddell. Kyle Gallagher. Daniel Goma. Benjamin Arthur Hammer. Sharvash Atul Ingawali. Grant Raymond Purdy McClellan. Yusuf Salim. Rohan Tangarash. Lauren Grace Waters. In naval architecture and marine engineering, Ahmed Osama Mohammed Hassan Ibrahim. Bradley Patterson. Ahmed Derin Yugun. In naval architecture with ocean engineering, Rotian Chen. For the degree of Bachelor of Science in Product Design and Innovation, Owen Clark Bruce. For the award of Postgraduate Diploma in Degree Apprenticeship Postgraduate Engineer in Engineering Management, William John Frater. In Advanced Mechanical Engineering, Juvarav Nilamegam. For the degree of Bachelor of Engineering in Engineering Design and Manufacture, Damon Alexander Christie. For the degree of Master of Science in Supply Chain and Logistics Management, Haojin Zong.
Well, good morning, everybody, and let me extend a warm welcome to all of you once again on this special day. And to all of our graduates, well done and welcome to the class of 2025. So all of you who are now graduates have shown great commitment, resilience, adaptability and perseverance to arrive at this special day. But none of you have done it alone. Every graduate has loved ones surrounding you. They may not have studied or sat all the exams, but they have been there for you. They have encouraged you and been the shoulder to cry on. They have been your inspiration, your support team, and perhaps at times your bank. You would not be here today without the support of your family, friends, and wider supporters. Likewise, our dedicated staff have worked tirelessly to provide you with an exceptional education and student experience, and your achievement reflects their commitment. So graduates, why don't you join me in thanking everybody that's helped you to get to this stage. But of course, this day is rightly about you, the class of 2025. In a short while, once we finish this ceremony, we will leave the hall in an academic procession, signifying that you are now full members of the Strathclyde academic community. And you're joining a family of more than 230,000 Strathclyders worldwide who have gone on to excel in their chosen fields. And Strathclyde is known as the place of useful learning, and it is through you and the thousands who have gone before you that this useful learning finds its purpose and its place. And we often celebrate the names you already know, the famous alumni whose achievements are recorded in headlines or history books. So at Strathclyde, we're rightly proud of the physician, missionary and explorer David Livingstone, or the inventor of the television, John Logie Baird. However, all of our graduates are the people shaping lives around the globe. They may not all be household names, but their influence is everywhere. They are the architects of progress, and they embody what useful learning really means. And today, you join their number as graduates of the University of Strathclyde, the place of useful learning. And it's that useful learning which informs our teaching, ensuring that our degree programmes equip you, our graduates, with the skills you need to excel in careers that will create a safer, more prosperous and sustainable world. It informs our research, which focuses on tackling practical, real-world challenges, such as the transition to clean energy, developing new healthcare, advancing manufacturing, quantum and AI technologies, and working towards a more just and equitable society. Useful learning fuels our graduates. It fuels you to help to create jobs, grow economies, increase prosperity, transform communities, improve people's lives, and ultimately make the world a better place. And at Strathclyde, across our faculties, we see this ethos brought to life in remarkable ways. And today, you're graduating from the Faculty of Engineering. And if we think about some of the few examples I have time to pick up on today, then what you'll find is our Faculty of Engineering is the largest in Scotland, and it brings together disciplines ranging from architecture and biomedical engineering to civil, mechanical, chemical, electrical and design engineering. It's the home to students and staff from across the world, and it inspires and equips them to think creatively, work collaboratively and lead responsibly, united by a drive to design, innovate and improve the way we live. Through initiatives such as the Scottish Space School and Engineering the Future for Girls, it opens doors for young people and broadens access to STEM, science, technology, engineering and mathematics education. In every project and every innovation and every graduate who goes on to build a better world, the Faculty of Engineering demonstrates what it means to turn knowledge into action and to use engineering as a force for progress, inclusion and human good. So an excellent example of this is a biomedical engineering project which is helping stroke survivors to benefit from specialist community gyms designed to improve their recovery and quality of life. In mechanical and aerospace engineering, Scotland's first national medical drone network could be a step closer following a pioneering project aiming to revolutionise healthcare logistics. As part of Project Careless, live flight trials were conducted across Scotland in 2024, using drones to rapidly transport medical supplies and diagnostic samples between mainland hospitals and remote rural locations, so making a real difference in the health of people and into society. And also, our people across the university are highly recognised for what they do. There are many we could choose across the different areas, but for today's graduation, let me pick up the fact that Professor David Nash on the stage today recently received the President's Award for Meritorious Service 2025 from the Institute of Mechanical Engineers. So this is the type of real-world impact that Strathclyde makes. It captures the spirit of Strathclyde, and it's something that's increasingly being recognised. Earlier this year, the Daily Mail named Strathclyde its UK University of the Year and called us the embodiment of everything a 21st century university should be. We are also the Sunday Times Scottish University of the Year 2026 and its UK University of the Year runner-up. These are the latest in a long line of awards and league table rankings. We don't pursue these awards directly, but they do demonstrate that our approach to teaching, to research, to partnership working, and to making a real difference is being noticed. A core part of our mission of useful learning is transforming academic excellence into real social and economic impact. So, for example, through the two innovation districts we helped establish, the Glasgow City Innovation District and the Advanced Manufacturing Innovation District, allied to our strong partnerships with major industry leaders, and sitting alongside our partnerships with the NHS, government bodies, and innovative small and medium enterprises, the university fosters collaboration and entrepreneurship. So now, as graduates of this university, you have the opportunity to take what you've learned here and to make your own mark on the world. During your time at Strathclyde, you've grown not just in knowledge, but in confidence, resilience, and perspective. And as Dame Lynn Gladden reflected on, you've learned to solve problems, to work with others, and to persevere when things get tough. And her messages around throwing yourself into challenges and not being afraid to use your skills and develop are absolutely key messages as you leave this hall today. But also, your journey here is not just about what you've studied. Just as importantly, it's about the friendships you've built, the experience you've shared, and the person you've become along the way. Education is not just about learning something, but about becoming someone. As graduates of Strathclyde and the future leaders of our society, you now have a responsibility to use your talents to make a positive difference. Whatever path you take in business, science, education, the arts, or public service, remember that you have the power to effect change and inspire others. Use that power with integrity, humility, and empathy, the qualities that will set you apart. You carry not only the knowledge and skills you've gained, but also the spirit of Strathclyde, a spirit of innovation, collaboration, and inclusion. Keep learning, keep questioning, and keep making a positive impact on the world around you. And as you move on, please stay connected with us. You'll always be part of this community, and your stories will inspire the next generation of Strathclyders to follow. Finally, let me again thank our staff for their dedication and excellence, and your families and friends who have supported you every step of the way. Congratulations once again on this remarkable achievement. You've made us proud, and you will continue to do so in the years ahead. Go forward with confidence, with purpose, and with the knowledge that you are capable of great things. I wish you all the best in your future career as you leave here as graduates of the University of Strathclyde. Thank you. Well, fortunately, it's still dry. So we are about to formally conclude the ceremony. I hope you've enjoyed it, and I hope you've enjoyed celebrating, and I hope our graduates have enjoyed picking up their degrees and are looking forward to the celebration after this. The academic procession will leave the hall, and can I then invite our new graduates to join in behind us and then followed by your friends, family, and loved ones to join us all at the Learning and Teaching building for an extension of the celebration and some refreshments. So with that, I'd like to formally declare this graduation ceremony closed. And if you can I please ask you to stand up?